and we will make the recording available after the call. We'll do some follow-ups. In terms of questions, if you have any immediate questions, feel free to use the chat function. We do monitor it. And as well as if you have a question that you'd like to ask live, just feel free to let us know and we can unmute you. With that, take it away, Zach.
All right, thank you, Adrian. I'll go ahead and turn on my video. I've got a sunny background. I'm actually working remote from Santa Barbara, California. So pretty exciting. That's what my background is, if anyone was wondering. Now, thank you all for taking some time out of your busy schedules, out of your day to spend some time learning more about Zepl. I put together some information about Zepl and also a workshop around building time series forecasts. The data that we're going to be using is we'll select a specific stock ticker, and we'll run through a few examples of actually getting our hands dirty in Zepl. Now, a little bit of housekeeping about myself. I'm a solutions architect. I also work as part of our support team. So for any of our existing customers, I'm always helping out with troubleshooting parts of the product, but also probably more importantly, exploring new use cases with our customers and seeing how Zepl can, or how we can continue to push the boundaries of what Zepl is capable of for our customers. So I'm really excited to share with you all a bit more about the platform, and whether you know anything about Zepl or nothing at all, this will be a good introductory session. As Adrian said, please feel free to ask questions. I want this to be as beneficial for you all as possible. So drop questions in the chat, and we'll address them. So what am I going to cover today? Why are you here? What are you going to see? So I'll start with talking about a few data science challenges in the different tool stacks that we commonly see our customers building. And then I'll jump into Zepl's approach to handling these challenges. And from there, we'll dive quickly into a demo. I have built out a notebook in Zepl that talks about time series, or that builds out a time series forecast to predict 30 days into the future for a specific stock price or target. The bullets down here that I have are sort of the requirements for the project that I was working on, or for the workshop. I had to take a set of data and create a 30-day target price for any given stock ticker, and then validate the accuracy through a shareable chart or graph. This is a pretty standard, I think, problem statement for a lot of data science problems, data exploration, whether you actually get to just visualizing results and doing some basic statistics, all the way through to building out advanced machine learning models. Zepl can support the breadth of that, and this is the subject matter for today. Some of the other requirements, though, that I thought was really important to call out are, in the workshop, I wanted to point out how myself as the data scientist and my team, I didn't have time to build out a really complex architecture on my own resources or on cloud resources. So things like Kubernetes, running multiple Python environments, running Spark, tuning Spark, and then also building in the Git workflow. Those are all parts of the stack that I needed to be able to accomplish this project, but I didn't have the time to actually build those out. The next requirement that I had for the workshop was that the team that I'm working on, or I guess I'll extend the folks on this call can be part of my team. I needed a way to be able to collaborate on the code that I've written, as well as the results. So being able to share either a runnable version of my notebook so that anyone can run it, or just provide a view-only version. That was another requirement. we can always, I wanted to be able to schedule these notebooks as a report and then be able to track all of the costs that may be incurred from running these resources. Okay, so those are the four main requirements that the workshop was based off of. If any of these different bullets resonate with you, or with your team, or parts of the tooling that you're using as a data science team, feel free to drop a note in the chat, or any questions about maybe how these might tune to relate to your specific use case. Okay. So from there, let's talk about the data science challenges and some of the tooling that we typically see, and then we'll jump into Zepl's approach. So the foundation behind all of the work that we're going to be doing is going to be on top of some sort of compute infrastructure, whether it's a shared server, or it's running locally on your laptop, or it's in some sort of infrastructure as a service provider, excuse me, like AWS, Azure, or GCP, which is not listed, but also, a very viable solution for this. So that's sort of the foundation for being able to run any code. And typically what we see is data scientists will rely on IT or cloud engineering to get access to these resources, which is great, but it can also provide introduce bottlenecks and slow down your team from actually getting to the analysis or the data science work that needs to be done. Okay. The second part of the stack is probably the compute engine that you're going to be running on. So how do we create reproducible environments? So I've got Kubernetes icon here. If you wanted to do anything that was containerized to make sure that you could reproduce your work on anyone's system, you might have to learn the backbone of Kubernetes, which is Docker, and start to orchestrate those different containers together, which can get very complicated very fast. Also, if you are looking to run large distributed jobs across Spark infrastructure, Spark is a great computational engine, and it scales really well, but you have to have a lot of knowledge. The barrier to entry is actually quite high to get that to run. So if you don't have someone on your team that has the time and expertise to learn that, it can be quite challenging. The next thing you might want to introduce is some external hooks into a Git workflow. I've got GitHub in there, or maybe make API calls externally to kick off other scheduled functions that you might have, using Airflow or something like that. And then lastly, on top of all of that is the actual interface to be able to write your code in multiple languages. So the data science notebook, these are two open source. Probably the most popular one is Jupyter. There's also Apache Zeppelin. Interestingly, some Zepl trivia for you guys. Zepl started from the open source project of Apache Zeppelin. So our community of users goes way back to when the Zeppelin project was fully open source, still is. But then the Zepl team actually spun off from the Zeppelin project, because we started to hear these, we started to hear a lot of the community asking for a more turnkey solution to being able to run all of these different technologies seamlessly without having to have a deep understanding of all of them, or to be able to save their team time because it was, because it was difficult to run, difficult to scale. So on the right-hand side here is sort of the Zepl approach, right? So what we've done is we've built out a SaaS service to allow you to use notebooks to power all the analytics, data science, machine learning models that you might need to build and train, all within inside of a fully hosted, fully managed service. We run on top of AWS, and are orchestrating Kubernetes to spin up Docker containers for you for every single notebook. So this doesn't require any cloud engineering or IT. We want to eliminate the bottlenecks for your team to get the resources that they need. It's fully, or Zepl will scale per notebook. So instead of having to build out a shared server and then scale that into it for everybody so that you accommodate for peak loads and so forth, we take a containerized approach so that you can scale one job at a time in its own isolated environment. So a lot of really big challenges that typically arise in the data science world with the technologies that you need to use to run, that we are simplifying dramatically here within inside of the Zepl service. So when we actually jump into the product, which will be soon, I hope that this sparks some good questions, and that I'm able to show you guys, how all of these different technologies play together, really nicely in our workshop. Okay. Now, I won't spend a lot of time on this, but just drilling into the different components of Zepl, I like to think of them as three major categories. Okay, the first category is around how do we make a cloud service that's very secure and secure to share all of the code that you might be working on, whether it's with technical users that need to actually run your code, or it's with maybe a business stakeholder or a project stakeholder that's asking you to deliver some sort of report from your notebooks. The second one is all of the cloud infrastructure that you might have to consider running and maintaining on your team if you were going to roll your own solution or build your own solution. And then the third is the interface and the integration. So how do we actually enable users to write multiple different languages inside of one notebook? Python, R, Spark, SQL, Markdown, right? Whatever it is. We've done a lot to unify this notebook experience so that it's very familiar to what you're used to using in Jupyter or Zeppelin, but also give you additional capabilities on top of that, like built-in visualizations, built-in version control, being able to schedule jobs and monitor those jobs and the success of running them, being able to share code using code snippets. And then, of course, we're not naive to think that we are the center of the universe. So we definitely have a lot of integrations into data sources. You can always bring your own files to Zepl in order to work on your own local data files that you might be working on. And then, of course, there's the output or the results of what you get. And we can talk about those as we go, but what you produce in Zepl doesn't have to stay there. Okay, so let's go ahead, dive into a demo where I can show you the Zepl platform. I'm going to stop sharing and pull up my other Chrome window. Thanks for your patience. All right. Okay. Adrian, can you just confirm again for me that you can see the Zepl window? I'll take silence as a yes. Great. Okay, so here we are in the login, or just after we logged into Zepl, and what I'm going to walk you guys through is, and I'm going to start with walking you through a notebook, and throughout the build out of this notebook, we'll run different code to be able to create a time series forecast based off a specific stock ticker. And as we're running through that, I'll explain, where all those different technologies come into play here in Zepl. The takeaway is that it's all built in to be anywhere from 1 to 3 clicks away from being able to do whatever you need to do in order to run your code. So here's the time series forecasting notebook that I've built. Let's step through it. The first thing that you're probably going to do when you build out or when you're doing any sort of data science experiment or project is you're going to need to have all of your libraries for whatever language you might be writing. Here you can see that I'm specifically writing Python. If you were using R, you could run R code or Spark Scala code, PySpark. We can run all of those within inside of the Zepl notebook. Now, what powers the ability to run all of those different languages is actually something that it makes it really easy to take anyone's code and run it on top of the Zepl platform and bring all of the same libraries and versions to any notebook across Zepl. So here, in this case, I'm actually doing an ad hoc installation of these libraries. All of these libraries are dependencies for this time series forecasting library, which is called Prophet, developed by Facebook. And that's what we're going to be using for our instruction here today. You always have the ability to install on the fly as you go different libraries. But in Zepl, we build out something called an image. And this image actually gets attached to the notebook. And it gets attached to the notebook with a set of interpreters. And these interpreters allow you to run multiple different languages like Python, R, and Spark. And you can see that I've got a whole bunch of preloaded libraries that make it really easy to get up and running without having to always install new libraries and so forth. So if you're a Python user, you're probably used to building and installing a virtual environment and doing that from a requirements.txt file or something of that nature. This is the easiest way in Zepl to take that concept and then apply it to any notebook that you have. Okay. So after we installed this, I actually ran the notebook before the meeting here so that we could get going faster. But once we install all of our libraries, we're going to want to import, this, the Prophet library. Okay. Actually, excuse me, everyone, just bear with me for a second. I'm going to go ahead and actually stop this last paragraph from running. And then I'll explain why as we get down here. Thanks for bearing with me. Always fun when you're demoing code live. So let's go ahead and rerun this import statement. Our paragraph starts and completes. Now we've got our library imported. We chose the Facebook Prophet library because it has a lot of great built-in functions for looking at time series data. The next thing we need to do is actually get our data. So this is sort of the first integration point with another technology. We happen to be using Snowflake as the underlying data store. But if you use if you have a data lake elsewhere, say in S3, or maybe you're using Azure Blob Storage, we can connect to those as well. Any relational database, Postgres database, we can of course connect to those. This code snippet here is what actually grabs the data from Snowflake. And you can see that we are getting our data source here, and we never have to expose any of our credentials in clear text in the notebook. And that's based off of the secure connections that we set up with our data sources over on the right-hand side of the screen. And I'll just show you really quick this Snowflake connection that I've created, where we have a specific account, specific warehouse that we're running, a database that we're connecting to, and a schema. And then on top of that, I've got my credentials. So this data source forces any user that wants to get access to this data will have to put in their own username and password credential. If I had single sign-on set up on Snowflake, we could go through the single sign-on workflow, which definitely supports multi-factor authentication and so forth. So we're really excited about this feature because it makes sure that all of your data and all of the data privacy that you've set up and access policies that you've set up in your data lake or data warehouse are always preserved on the Zepl side. Okay. Keep in mind, if I shared this with Adrian and Adrian wanted to use this data source to connect to this database, he would have to put in his own credentials as well to be able to successfully authenticate into Zepl, or sorry, into the Snowflake data warehouse. It looked like there may have been a question in the chat. Okay, Adrian's just prompting everyone. Yeah, please, if you have any questions, I'm going too fast, too slow, please let me know. Awesome. Okay, so so far we've installed all of our libraries into the at the start of the notebook, and now we've connected to data. So let's go ahead and actually run this. And what's happening is that we're running a query, pushing that query down into the database, and retrieving a result back as a Spark data frame. Okay, so you can see that this is actually running. I'm not just BSing you as we go. I'm going to create a new paragraph here and just show you all what the data looks like. Okay. We have a built-in visualization editor and a custom function here called z.show. And what that does is it allows you to render the first 1,000 rows of your data frame to really easily be able to look at what does our data look like. So we have date, a timestamp, which is going to be really important for looking at this data for time series. We're looking at the Johnson & Johnson stock ticker, and we have open, high, low, close values and adjusted close for all of the data going back for, I think it goes back about 30 years for this, this stock price. All right, so just a quick overview of what that looks like. We have a lot of, inside of the visualization editor, you can also plot different charts. And just to quickly, show what this looks like as this loads. Just to quickly show, what this looks like. We want to be able to give the less technically savvy users the ability to create visualizations on the fly. And of course, let me go ahead and pull up a different example. So we can drag and drop different columns from our data frame directly into our chart here, and looking at things like open and close values over time. Okay. So I'm going to go back and actually just hide the output here so we can move forward. Now, I mentioned a few other data types and data sources that you might want to use. You can see down here that other members of my team have used or created different data sources for S3, Postgres, Google BigQuery, and so forth. And just to give you a flavor of kind of what that looks like, you can always go ahead and create new data sources here inside of Zepl. If you have any generic strings that you want to connect to, say an API call externally, we have a secret store, which will actually just store a generic string securely, and then you can access it securely inside of the notebook. All right, so from there, let's move on. Let's go through the prediction model. I'll explain what this code is doing. So we create a profit object from the profit library and take the data that we have from our stock data and drop a few columns. We actually only want to look at our adjusted close value, that's our prediction value, and our date timestamp, which is called date in our data set. Then what this does is it'll actually fit this model on the data that we pass in, and assign values to this new data frame, which we're going to create down here. So now we get to specify how many days into the future we want to predict. I just set a target, based off of requirements for 30 days, and I'm taking advantage of the profit library's make future data frames function here and predict function to basically take an empty data frame, give it 30 columns, or sorry, 30 rows to store all of our data. When we make our predictions, here's what the output of the results look like. So we have our date timestamp into the future. So you can see, we're going to be looking at future dates, April and May. We can see the predicted trend value, the confidence intervals, or lower and upper, basically looking at how confident we are that this trend is within a certain range, and we can plot lower and upper intervals there. And then a few other pieces of information about weekly and yearly trends that the profit algorithm is generating for us. Okay, so what does that actually look like as a chart? So before, I was showing you all a chart that uses Plotly behind the scenes and allows us to drag and drop or click through elements. You also are probably familiar with using other plotting technologies or libraries like Matplotlib and Seaborn and so forth. If you're writing R, you're probably using ggplot2 or something like that. Because because we come from the Zeppelin open source data science notebook world, we also empower you or allow you to generate graphs using any library that you need. So you aren't limited to the built-in show function that I was showing you earlier. And that's what I'm doing here. I'm taking a Matplotlib chart and I'm actually plotting the forecast along this graph. So the black dots are our close values, or adjusted close values. And the solid blue line here is our trend. So we're going to use that trend in order to set a target price for into 30 days into the future. And you can see that, visually the trend seems to be very close to the center of all of the close values. Something else that I think is really interesting is the seasonality within that the profit algorithm looks at. And so this is something that you can actually tune by using this library, is taking a look at weekly or yearly trends. So if we take the yearly trend, can we say that how impactful in a positive or negative direction is year-over-year comparison by these months? So it looks like our highest increase happens year-over-year around the November-December timeframe, end of year. And perhaps this is something that you want to consider is maybe holiday seasons for different companies and so forth. Janssen & Janssen is one that I chose. I thought it was interesting with recent news about COVID vaccines and so forth. So I thought I wonder if there's any sort of fluctuation that we might be able to determine in the future. Definitely a forward-looking project for recognizing that. We're keeping this pretty simple to start off with. All right. So now that we've made our forecast and our trend, what we're actually going to do is look at our last known price and our 30 days into the future forecasted price, and then project a difference. So it looks like within 30 days in the future, what we're projecting is a price that's $2.16 below what the last known close value was. All right, so I'm going to go out on a limb and say we don't really actually know at all. And it's really hard to predict stock prices because there's so many external forces that may influence the price. So, you might be on the other side of the phone saying, this is probably not the best data source to run time series forecasts on. More than anything, I want to use this as a workshop so that you all can apply the learnings that you get here, how to actually use Zepl in a really quick and easy way to get up and running, and apply it to your own time series use cases in your time series data. So we took stock price because it's an easy to get, easy to access data source. Okay, so let's say that we are projecting a small decline in a 30-day window of $2.16 from our last known value. We can zoom in on that chart and look at where our trend passes to our into the future, our 30-day projections. And then I think the most important part here is to actually then get into our cross validation. So cross-validation is going to tell us how confident we are that our price, that our target price is going to actually be met. So we take the cross-validation function that's built into the profit diagnostics library and pass in a few parameters. So we're passing in our model, our profit object. And then we're saying, let's train based off of the last 657 days. And then we'll take a set period that we want to, we'll take a horizon, which is the period of time that you want to actually validate the predicted values with the known values. And then we'll have a 180-day lull in between those. Okay, so we can start to get we can validate about one quarter per year is kind of what we're targeting with this cross validation. Okay, and once this runs, you can see we're running this in parallel across multiple CPUs. And once this runs, we'll get a prediction value here, our Y. Our Y hat is our prediction value, and a comparison between the actual known value on that given day. So let's say, for example, we're in April 8th, we get a prediction of 152.97, and our actual known close value was 162.97 So we start to look at those, and then we can produce some diagnostics around the error, the known error. So there's a few different performance metrics that we might want to consider. Here I've plotted them against the chart so we can look at all of our errors. So the mean squared error. We're also going to look at the average percentage error as well. So this number is saying that on average, we are 12% away from the actual value. And what that looks like, this paragraph failed, and I'm not sure exactly why. We can revisit that in a second. But I guess more importantly, what that looks like here on our chart is an error that hovers around 10 to 11 or 12% on average that we are away from the actual value. Okay, that's really nice. What does that mean? Well, in terms of stock prices, how much risk are you willing to take on to actually invest your own money into the stock market to say that we think that our predicted stock price is actually going to be in 30 days $2 cheaper than where it was. So essentially we can from start to finish here, we can take a time series data set, our stock values, make a quick prediction using the profit library, and then validate our findings. I definitely think that the percentage error that we were looking at there at 12% is something that we could definitely improve upon. So, it might be the next step to look at, how do we do any sort of hyperparameter tuning to actually improve our prediction values. So they have a way to easily run our cross validation over a for loop of multiple different permutations of these different parameters. In this case, what we're looking at is a change point and a seasonality scaling factor. there's actually a lot of different parameters that you can tune on with this library. I just happen to take these two, for this example. And so the idea here is that we want to take our original weights and compare them against a whole bunch of different weights and see what the best one is as we run through our cross-validation. Okay, and as this runs, I'm going to, so I stopped this at the beginning of the session here because sometimes it can take a long time to actually run these, and that's why we parallelize the solution, the cross-validation across multiple CPUs. But even still, one thing that I could do here is take a look at my version history. And when I first imported this notebook, I believe I had a result for this cell. And so something that's built inside of Zepl is a version history where we automatically take snapshots of your code changes, which is very much like GitHub or a Git workflow. And then we also take snapshots of your result changes. That's a little bit different than what a standard Git repository does. So when people come to me and say, can we take the versions from here and commit them back into our private Git repository, the answer is yes, we can. However, it's really nice to be able to have this interface where we take snapshots of the actual output of every paragraph. The reason being that these paragraphs might change every time your model runs or every time your notebook runs. And so you want to be able to have a historical record of the actual output, which isn't something that you typically get using just standard Git interface. All right, and of course you can always roll these back or create your own, create your own snapshots or versions. Okay. So I've been through this entire time series forecast example, and I have failed to show you all one super important factor here. So we touched on in the beginning, like how Zepl or all of the different technologies that you might want to use on top of your or underneath your data science notebooks. One thing that Zepl does that is very different than all of the other solutions that I've seen on the market is you can see here that we have a container that's running, and this container is 32 gigabytes in size. Okay, it's been running for a certain period of time, and it's set to shut down after 60 minutes of idle time. The difference here between what other solutions do in Zepl is this is a fully dedicated container for this one notebook, and it isn't going to be queued. Like the process and the job that gets run whenever you click run on the cell, you aren't going to be queued in on a shared server or a shared cluster. And if your process fails, it isn't going to impact anyone else's, which makes for troubleshooting extremely easy and fast. And you can always stop these containers and scale them up or down depending on whatever your project needs. So as you start to work with larger data sets, we can support larger and larger containers. Likewise, if you are doing a lot of processing just in your data warehouse from the notebook and you just need a really lightweight footprint, you can spin up really small containers, be extremely effective with with the container sizes and the credits that you consume. Okay. Awesome. So with that, I'm gonna pause there and see if there's any questions. There's about 2 more things that I want to get into because I had a few other requirements for this workshop, which were around sharing notebooks and sharing code, as well as scheduling. So I'll just pause though really quick and see if there's any questions. Okay. Okay, so let me just touch really quick on how we make sharing code and sharing notebooks really easy in Zepl. So a few things. You're going to have, likely you'll have the need to share a notebook and all the code intact so that anyone can run it. The way that we do that here in Zepl is we create these spaces. They're like shared folders, for example. And in a space, you can actually invite other teammates to collaborate on your notebook. So in this case, I have a data engineering team that I work with, and I want to be able to share my notebooks with them. I want them to be able to clone them, but I don't want them to actually run the code. So make a copy. You can read and write comments, but you can't actually run it. Similarly, with my data science team, I want to be able to collaborate on the same notebook, do pair coding with folks on the same notebook. So I'll give full access, to these different privileges and permissions. So something that can be kind of complex in a Git environment where something runs on my computer but it doesn't run on someone else's. This does away with all of those conflicts and challenges. Similarly, you might have users that are stakeholders that just want to see reports. So you can give those users just full read access and only be able to read and view the content. Now, when you're actually inside of your notebooks here, you're probably going to want to send a link to somebody to be able to access the notebook. If they have got an account, you can send them this link where they'll have to actually enter in their password, or you can send a public link by actually publishing these notebooks to the web and send a published URL. And now this is going to reflect all of the changes, most up-to-date version of your notebook when you actually render the published view. That includes things like any output that changes, or even if you set your notebook to be more of a dashboard view, this is a really nice workflow to be able to create, turn your notebook directly into a dashboard and actually only display the results that you're getting, and turn this into more of a data app, if you will. But again, you can always switch it back and start editing your code as well right in line. Now, the last requirement that I had for the project, this virtual workshop, was actually being able to schedule these jobs to run. So we have our containers that I showed you that spin up ad hoc automatically. You get to set the size as you want, and you can attach whatever libraries that you need. Now, if we want to actually orchestrate that to run on a repeatable schedule, we can set that inside of the notebook here. So we'll call this maybe virtual workshop, stock forecast, and we'll set this to run every, once a month to update our data. Maybe we create a forecast and we write it back to Snowflake. Let's go ahead and create this. And where that shows up is in our monitoring section for our scheduled jobs. So here's our virtual, our workshop, the status and schedule to run our notebooks, and whether it has completed successfully, and then the date that it was last run. So a lot of great monitoring that's built into Zepl that makes it really easy. So you don't have to spend time troubleshooting cron jobs or setting up your own cron server to actually kick off workflows. You can do that all within inside of Zepl here. Okay, and of course, since our workshop's coming to a close, I'm going to actually just pause this, and we can always restart it when we need. So let me go back to our presentation and just recount, what we've covered. So far, what we walked through today was talking about the different technologies and the tool stacks that typical data science teams wrestle with. And then we discussed how Zepl approaches that problem as a managed service, giving you the ability to run Kubernetes and Spark all on top of infrastructure providers like AWS. And then we walked through an example of how we actually do that by creating a stock forecast 30 days into the future and delivering that to multiple teams, as a shared resource in both chart, graph, and dashboard format. Now, the last thing that I didn't talk about was cost. And the nice thing about Zepl is that right now that I'm talking to you guys, I'm not being charged for anything. And that's because I stopped my container when I was done working. So the only time that you ever get charged in Zepl is when you're actually running a container. You pay once for those credits. You don't also have to pay for your AWS bill as well. It's only a Zepl credit that you have to consider. So it becomes a really nice way to track costs as well as also optimize on those resources, because again, you get to use the right size resource for the job that you're running. Okay. So from here, I'm going to go ahead and just pause and see what questions there are, and we can discuss. We can discuss the next steps. Are there any questions?
Feel free to drop any question in the chat box, or we can unmute you if you'd like that as well. Okay, Zach, continue.
Sure. Okay, so as closing remarks here, guys, typically the next steps are to have you go and sign up for a free trial of Zepl. You can, with our free trial, you get 30 days to use the product, and you get 25 free credits, $100 in free credits. If you do sign up, oftentimes we engage with our trial customers and talk to them about, what's a good use case for you? What data are you working with? And we can help you get started, really quickly connecting up the data, start bringing in or importing your existing notebooks. I'll be more than happy to talk with you. So if you would like, if you would like to do a guided trial like that, feel free to reach out to us. My email is Zack, Z-A-C-K, @zepl.com. Where you can always write into our support channel, support@zepl.com. Signing up for Zepl and once you get past the free trial, it's only a $25 activation fee every month, and that gives you access to unlimited users inside of Zepl, and the $25 goes towards the credits that you use. So really cost-effective solution to start getting your teams up and running on their data science notebooks on Zepl. And with that,
Great job.
I'll pass it back to you.
Great, thank you. Great job, Zach. I hope everyone found this virtual workshop beneficial. Just a couple of follow-ups here. We will be sending out the recording within 1 business day. Our next virtual workshop will be in 2 weeks, and we'll send out the calendar for that. In addition, hot off the press, this week we actually got mentioned by Analytics Insight as one of the top 10 data science platforms for massive disruption. So you can find that article on my LinkedIn profile, and I'll be sending out some LinkedIn connections. Thank you again for joining us, and look for the follow-up emails tomorrow. Have a great afternoon.